All right, 4.4, part 4, we're factoring perfect squares. I'm going to list the perfect squares. So if we have 1 times 1, 1 times 1, that gives us 1. That means 1 is a perfect square, because two of the same things multiply by each other and give us that as our answer. If we have 2 times 2, that means 4 is a perfect square. 3 times 3, 9 is a perfect square. 4 times 4 would be 16 is a perfect square. 5 times 5, 25 is a perfect square. 6 times 6, 36 is a perfect square. 7 times 7, 49 is a perfect square. 8 times 8, 64 is a perfect square. And 9 times 9, 81 is a perfect square, and this keeps going. 10 times 10, 100 would be a perfect square. 11 times 11, 121 would be a perfect square. So we just keep going. I don't think we'll see any numbers higher than 81 in today's notes or on the homework. So all of these over here are perfect squares. Perfect squares. If we take the square root of any of these numbers, so let's pick 25, and we take the square root of 25, that gives us 5. So just keep that in mind. So since 25 is a perfect square, we take the square root, we get whatever times itself gives us that number. So keep that in mind as we do the next examples today. All right, so we have perfect square binomials. If our first term is a perfect square, and our last term is a perfect square, then we can use this formula here, a plus b in parentheses squared. But we just have to find out what our a is and what our b is. So right now we have a squared. That color is hard to see, so let me change. A squared is equal to x squared. So if we take the square root of both sides, that would give us a is equal to, what do you think a all by itself is equal to? If a squared is equal to x squared, what's a? X. Perfect. Our a term will always have an x in it, so that x will always be in our a term. And then we have b squared is equal to 25. So if we take the square root of both sides, what is b equal to? 5. Perfect, because 25 is a perfect square, and 5 times 5 would give us 25. So we have our a and our b. We can take those and plug them into our formula up here. So we have a, which is x, plus b, which is 5, squared. So this is our answer. This is our factored form. So when we start to have numbers like big perfect squares, so like 81, 100, it's easier to use this formula than it would be to like multiply the first and last terms together, or just find like the two factors of the last one. Like this one, we can solve it the same way we did in part 1 and find the two factors of 25 that add up to 10. It wouldn't be too hard to do it that way, but as we start to get to bigger numbers, it gets harder to do it that way. So that's why this handy dandy formula is helpful. So in the past, I've made the kids memorize this formula, but you guys will be able to use your notes on the next test, so this formula will be given to you. So when you do your homework, make sure you have this formula, and I think there's 2 others that we're going to use today. Have them in front of you to do your homework, because it'll help a lot. Since you'll have it in front of you for the test, you want to have it in front of you when you do the homework. Any questions on this one? All right, our next example. So we see 36x squared is a perfect square, and 4 is a perfect square. So we can use our formula. So we have x, or a squared, because our first term is our a, so a squared is equal to 36x squared. What do you think our a is? Awesome. 6x. So our a is always going to have an x in it, since our a squared always has the x squared. And then 36 is a perfect square because 6 times 6 gives us 36. So we get 6x. Now we do the same thing for b. So b squared is equal to 4. What is just b? 2. Awesome, because 2 times 2 is 4. So now we plug those into our formula. We have our a plus b, so 6x plus 2 squared. And that's our answer. So this formula is a little bit different. Whenever we have a minus sign in our equation, we have a minus in our answer. So before, everything had a plus, so our answer had a plus. Now it's just a little bit different. Our middle term is going to have a minus, so we put the minus in the middle. So we see 4x squared is perfect square and 36 is perfect square, so we can use our formula. We have a squared is 4x squared. So what is our a? Awesome, 2x. Because 2 times 2 gives us 4, and x times x gives us x squared. And b squared is equal to 36. So what is our b? 6. Perfect. Everybody sees how we get the a and b? This is 6. Everybody's good with that? So now we just plug it into our formula up here. So we have a, which is 2x, minus b, which is 6, squared. So this is our answer. So again, for this one, we started with a minus in our problem, so we have a minus in our answer too. All right. So we see that 64, x squared is perfect square, and 1 is perfect square. So if a squared is 64x squared, what is a? 8x. Awesome, because 8 times 8 is 64. And then what is b? If b squared is equal to 1. 1. Just 1. Well, the minus goes into our equation anyway, so. So 1 times 1 is 1, so our b is 1. Now we just put a minus b into our parentheses, so we have 8x minus 1 squared. So since we had a minus in our equation, we have a minus in our answer. That's a good question. So we're taking like the square root of this and the square root of this. So we need to find like what times what gives us 64 and what times what gives us x squared. So if we square both of these sides to get our a to be a squared, we have to square the 8x. So this would be a squared is equal to 8x times 8x, because we're squaring it. So the 8 times 8 would give us 64, and the x times x would give us x squared. If we started out with an x squared here, when we square it, then we would have 4 x's, which is not what we want in the beginning here. So we're pretty much cutting it in half to find what our a is, which not really cutting it in half because we're not dividing by 2, but we are seeing what times what gives us this original here. So we need that x times x to give us x squared. So it's not x squared times x squared, because then we would have too many x's. Does that make sense? All right, here's a different formula that we have. So we use this formula when we have two terms. So use when we have two terms. And when they are both perfect squares. So we see we only have two terms. We have this one and we have this one. And we're always going to be subtracting the two perfect squares. So in this one, we always start with subtraction in between our two terms, and it becomes plus and minus in our answer. So we do the same thing as before. Our a squared is equal to 25x squared. So what is our a equal to? 5. What? What are we missing? 5x. Perfect. Remember, our a always has an x. And then our b is 49. Our b squared is 49. So what's our b?
7.
Awesome. 7 times 7 gives us 49. Perfect. So
It's not negative 49?
it's not negative because we're always going to have a negative there. So we're only looking for like the positive b.
Oh.
So it'll always be, your b squared will always be positive, and your a and b will always be positive. You just have to keep the equation the same here. So it'll give you the formula. All you do is plug in your a and b, and the signs stay the same. So we have a plus b and a minus b. So what's our a? 5x. What's our b? 7. What's our a? 5x. And our b is 7. So this is our answer. So our signs stay the same as they were in the equation. We have a plus and a minus. So we use that same formula we had before because we have two terms, and those two terms are both perfect squares. So we have a squared is equal to 16x squared. So what is our a equal to? 4 what? 4x. Our a always has that x in it. And then if our b is 81, b squared is 81, what's our b? 9. Perfect. So our parentheses go a plus b, then a minus b. So what goes into our first parentheses?
4x. Well, it doesn't matter what order it's in, like,
It doesn't matter.
4x minus 9. 4x plus.
Perfect. So Nick asked, does it matter what order we go in? Can we put the plus first and then the minus, or the minus then the plus? It doesn't matter. Because it would be like saying 2 times 4 is the same thing as 4 times 2. So it doesn't matter the order that you multiply it, just as long as your a goes before your b. But we could put the minus in the first parentheses if we wanted. So this is our answer.